Hello students, today we are going to learn trigonometry part 3. So in this part 3, we will see how the ratios in 4 quadrants changes. So for that, I am going to consider the trigonometry part. Trigonometry, this is part 3. Already part 1, part 2 already over. That video is also uploaded. Now in this, I am going to consider a plane. In this plane, coordinate axis I am going to calculate. First x dash. This is x axis. Next y axis also I will consider. Y dash. So x axis divide the plane into 2 parts horizontally, and y axis divide the plane into 2 parts vertically. So this is the positive x axis, and this is positive x axis. This is negative x axis. Here to here we will get negative values. This is intersection part of x axis and y axis is origin, and this is positive y axis. And this is negative y axis. In this x values you have positive x values, and then from 0 to left side negative x values you get. The same way on y axis, above the 0 you will get positive values, below the 0 you will get negative values. So this axis, 2 axes, divide the plane into 4 quadrants. We named this one as the first quadrant, denoted by Q1, Roman number 1. This is second quadrant, it is denoted by Q2 or Roman number 2. This is third quadrant, it is denoted by Q3 or Roman number 3. And this is fourth quadrant, denoted by Q4 and Roman number 4. Okay, in these quadrants, so each quadrant measures 90 degrees angle of the origin. So total angle is 360 degrees. Total angle is 360 degrees. So if I take the radius vector OP is the radius vector, and if I consider a angle which this radius vector makes with the x-axis, let it be theta. So the opposite to the theta, we will draw a perpendicular falling from P2 on x-axis. Let it be M. PM is the perpendicular drawn from P to M. And this will become OPM is become right angle triangle. In this right angle triangle, this opposite side we measured. This value we measured on y-axis. So this value I am keeping y, and this adjacent side of this triangle angle that we measured on x-axis, let it be x, and this radius vector, let it be r. Okay. So when angle gradually increases like this, then it will changes. This radius vector first in first quadrant, second, third, fourth quadrants. So it will move in all quadrants by moving anti-clockwise. Okay. So if you take all trigonometric ratios, you should remember this formula, or silver teacups. In your intermediate book and state books, we have this all silver teacups. In engineering books, all students take coffee. Take coffee. That means you have to consider the first letter A here. This is all you have to consider. Here you have to consider first letter. Now student or silver. Here also you consider first letter. First letter. All means all trigonometric ratios in the first quadrant are positive because the x-axis giving positive value and y-axis also giving positive value. So x is positive, y also positive. X is greater than 0, y also greater than 0. Also all trigonometric ratios sine, cos, tan, cosecant, secant, cot, all are positive. All are positive in first quadrant. That means sine theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. If theta is the acute angle, then all trigonometric ratios use the positive value. Next, when trigonometric ratios falls in second quadrant, only two ratios will become positive in this second quadrant. Remaining all are negative. What are those two ratios? Let us see. Those ratios are sine is over no? Sine and cosecant. These two ratios are positive in second quadrant. Next, in third quadrant, tan, cot are positive. So when trigonometric ratios falls in second quadrant, only sine cosecant become positive, remaining all ratios become negative. When the ratios falls in the fourth quadrant, that is 180 degrees plus theta. This is 0 degrees, no? 0 degrees, 90 degrees, this is 180 degrees, this is 270 degrees. And again it completes 360 degrees. So this is 0 plus theta or 0 minus theta. And also we can write 360 plus theta or 360 minus theta. So 360 plus theta, 0 plus theta falls in first quadrant, 0 minus theta, 360 minus theta falls in fourth quadrant. Here 90, no? So 90 minus theta. 90 minus theta falls in first quadrant, 90 plus theta falls in second quadrant. When angle becomes, it is 180 now, 180 minus theta falls in second quadrant, 180 plus theta, 180 plus theta falls in third quadrant. Next here, if you see this one, 270 degrees. So 270 minus theta, which is less than 270 degrees. 270 minus theta falls in third quadrant. 270 plus theta falls in fourth quadrant. So when ratio rises more than 90 degrees and theta is acute angle, then it falls in second quadrant. When ratio, trigonometric ratio, angle rises more than 180 degrees and theta is acute angle, then it falls in third. When trigonometric ratio angle rises more than 270 degrees and less than 360 degrees, it falls in fourth quadrant. Okay, so this you have to remember. In fourth quadrant, this letter is C, no? So cos, the secant ratios become positive. So you should remember this one. When the theta is lies between 0 and 90, including 0, theta ratio is positive. Its value is positive. When theta is in second quadrant between 90 and 180 degrees, its value sine and cos become positive. Remaining all ratios become negative. When trigonometric ratios falls in third quadrant, only tan cot become positive. Remaining all ratios become negative. When same way trigonometric ratios falls in fourth quadrant, So cos secant become positive, remaining all are negative values it gives. So now carefully observe how the ratios changes on y-axis when the ratios are operated on y-axis, when the ratios are operated on x-axis. The ratios can be operated in two axes, on x-axis and y-axis. What are the operations on x-axis? 0 plus theta, 360 plus theta. 0 minus theta, 360 minus theta. 180 minus theta, 180 plus theta. These operations are making on x-axis. These operations are happening on the x-axis. This coming to 90 minus theta, 90 plus theta. 270 minus theta, 270 plus theta. These operations are occurring on the y-axis. So now carefully observe, if you take a sine theta here, so sine theta. So theta is acute angle. If theta is acute angle. If theta is acute angle. So then sine theta. So sine theta means some value take. Sine theta is acute angle. So it falls in first quadrant. It falls in first quadrant means this value is positive. Sine is positive. Not only sine, all trigonometric ratios which falls when they falls in first quadrant, the angle is acute angle. Then that value is positive. Not only acute angle, if angle is more than 360 and less than, if you add 90 to this one, less than 450, it also falls in first quadrant. Whatever ratio if they falls in first quadrant, that gives the positive value. So suppose I am taking a sine 90 minus theta. 90 minus theta means where the sine falls, it falls in first quadrant only. 90 minus theta. So 90 minus theta, we have to take this total is 90. You have to subtract this theta. So if you subtract this theta, what you get here? This is 90 minus theta. So 90 minus theta means in this right angle triangle. This is the right angle triangle here. Here right angle triangle forms. So carefully observe this right angle triangle. So this y we measured on y-axis. This x is measured on here because it is a rectangle. Opposite sides are equal. This is y means this one also become y. This is x means this one also become x. So now see theta. What is the opposite here? Y. Opposite side is y here. And hypotenuse. We know the sine ratio. What is the ratio of the sine? Sine theta. Sine theta is equal to, that is opposite side by hypotenuse. We already know. Opposite side by hypotenuse. That is y by x. It falls in first quadrant. No? Positive value will get. Positive sine theta will get in first quadrant. And also ratio does not changes in first quadrant. So if the sine 90 plus theta, 90 minus theta, 90 minus theta will take. Sine 90 minus theta. Okay. So sine 90 minus theta means the opposite to the sine, this angle is x. And this is hypotenuse. There is no change in hypotenuse. This is adjacent side. Okay. Now this opposite side becomes here adjacent side to the 90 minus theta. Here y is becoming adjacent to this triangle. In this triangle, y is becoming adjacent side, and x becoming opposite side. Clear? Here x becoming opposite side. But this opposite side in this triangle, opposite side will becoming adjacent side in this triangle. So ratio changes here. Whenever it comes 90 minus theta, this opposite side by hypotenuse y by x, y by not x, this one r, y by r. Hypotenuse means r no. So y by r becomes, so y comes here now. So here y is the adjacent side and r is common. Y by r. So what it become? Adjacent side by hypotenuse. So adjacent side by hypotenuse. Again 90 minus theta means it falls in first quadrant. So first quadrant plus plus. Both are plus only. Both are plus means x value also plus, y value also plus. So both are greater than 0. So this is y is plus and x also plus, and r is a radius vector. Radius vector is always positive. So adjacent side by hypotenuse is nothing but what? It will become cos ratio, no? Cos theta. What it become? Cos theta. So sin 90 minus theta will become plus cos theta. That's cos theta. Okay, clear? So next 90 plus theta we will take. 90 plus theta means it falls in second quadrant. P comes here. So this is 90. So that means here 90 minus theta means if you remove the theta from this, from 90, here you have to remove theta. So where you have to remove theta? Here somewhere it comes. Actually it comes somewhere here. 90, and this is theta. So we are subtracting theta, same value, theta are same value. Then this one become x, this one y. So 90 minus theta. So that will become 90 minus theta will become cos theta. Adjacent side by hypotenuse. Hypotenuse, this is r1. So same way, this is 90 plus theta plus theta. So 90 plus theta. So we know that this is y, this is x, this is radius vector. So now carefully observe. In the second quadrant, what happens? In first quadrant, sine is opposite side is y and hypotenuse is r. So sine 90 plus theta. So what will get here? Opposite side plus y. So opposite side is y. Simply take y. And hypotenuse is r. So now you see this opposite side is coming here. So in this triangle, in this right angle triangle, this opposite side is adjacent side to this theta. So that is the y value. What happens to the y value here? Here we will observe here x greater, y greater. Here x is a negative values less than 0 and y is positive values. So that means minus plus will come. So here both are negative values. Both are negative values. That means x is less than 0, y is less than 0 in this quadrant. Here you observe, so x is positive value, y is negative value. That means x is greater than 0, y is less than 0. Here what you get? Both are negative here, I will write. So in this quadrant, x value also negative, y value also negative. So x is less than 0, y also less than 0. Is it clear? So now you see x is less than 0, y is greater than 0, y is positive value, x is negative value. Now this one opposite side by hypotenuse will become, y will become adjacent side here, adjacent side by hypotenuse. Here adjacent side we will measure on y axis. Y axis is positive, y values are positive, so this is positive. Radius vector is always positive, but when it falls in second quadrant, so opposite side will become adjacent side. So opposite side will become adjacent side, and hypotenuse there will be no change. So this ratio will changes, but sine no change, plus only comes. So sine become cos. Not only sine, tan also changes because this opposite side by adjacent side. So this opposite side will become adjacent side, and adjacent side will become opposite side. So that means tan becomes cot, sine becomes cos. Like that, secant also changes. What is the ratio of the cos? First we take cos ratio adjacent side by hypotenuse. So when it falls here, this adjacent side becomes opposite side, and hypotenuse no change. In the same way, cosecant also changes. Cosecant means that is a hypotenuse side by opposite side. So this opposite side will become adjacent side by hypotenuse. That will become cos. In the same way, there is not a cosecant. Cosecant means what we take cosecant is reciprocal of sine. So hypotenuse side by opposite side. This one become hypotenuse side by adjacent side. Ratio changes. Is it clear? Is it clear? So ratio changes. So the ratio doesn't remember. So sine become cos. Cos become sine. Cos become sine. Cos will become sine. Cos what? Adjacent side by hypotenuse. So this will become opposite side by hypotenuse. So cos become sine. Sine become cos. And same way tan becomes cot. And cot becomes tan. Here sine becomes cos and cos becomes sine on the y-axis. Same way here also operation on y-axis, ratio changes. So secant becomes cosecant and cosecant becomes secant. So when you operate on y-axis, ratio changes. So sine when falls in second quadrant, and we operate with these angles 90 minus theta, 90 plus theta, or 270 minus theta, 270 plus theta. That means if you operate the ratios on y-axis, the ratios changes. Sine will changes into cos, cos will changes into sine. Same way tan changes into cot, cot changes into tan. Secant changes into cosecant, cosecant changes into secant. Is it clear? So same way if you operate the trigonometric ratios on x-axis. Not only that, this sign also changes. So here these two are positive values. It gives positive values, sine and cosecant. Sine and cosecant are positive in second quadrant. In third quadrant, tan and cot are positive. Fourth quadrant, cos and secant are positive. Remaining all negative becomes. So if you operate same thing on the x-axis. So let us see. On x-axis. 360 minus theta or 0 minus theta. It falls in fourth quadrant. So this is a adjacent side. This is y. Okay. Sin theta if you take means y by r. Y by r. Sin theta is equal to opposite side by hypotenuse. Their opposite side is y by r. So when it falls fourth quadrant, the opposite side, so this is the theta comes here, 0 minus theta, theta comes, or 360, total 360 minus theta, if you subtract theta, it falls in fourth quadrant. So here opposite to theta is y only, there is no changing. Here also opposite to theta is y, and hypotenuse also not changing, adjacent side also not changing. So there will be no change in the opposite side, that is y value. So this will remains opposite only and this remains hypotenuse only. So ratio does not changes. But in fourth quadrant, sign is not there. No? Cos, secant only become positive. Remaining all values become negative. So sign is not there. Negative sign will come. Ratio does not changes. So when you operate the trigonometric ratios on x-axis like this, 0 plus theta or 360 plus theta, 0 minus theta or 360 minus theta, or 180 minus theta or 180 plus theta. The ratios does not change. Ratios will come as it is, but signs may be changed. Plus or negative sign may be changed according to this one. Sin cos does not change. Cosecant does not change in second quadrant. 90 minus theta. When 180 plus theta, tan cot does not change its signs. Positive only. These two are positive only. Not only that, 270 minus theta positive. 270 plus theta cos secant positive, and 360 minus theta, 0 minus theta cos secant become positive in fourth quadrant. That you should remember. So how the ratios changes you should remember. Simply you should remember whenever we operate the trigonometric ratios on y-axis. So that means what are the operations on y-axis? 90 minus theta, 90 plus theta, 270 minus theta, 270 plus theta. Whenever we operate trigonometric ratios with these angles, 90 minus theta or 90 plus theta, 270 minus theta, 270 plus theta, the ratios changes. How the ratio changes carefully observe here. Sin will become cos. Cos will become sin. Tan will become cot. Cot will become tan. Secant will become cosecant. and the cosecant will become secant. That you should remember. And when the trigonometric ratios here in first quadrant, whatever the trigonometric ratios falls in first quadrant, all are positive. When the trigonometric ratios falls in second quadrant, only sine and cosecant is positive. And when trigonometric ratios falls in third quadrant, that is tan cot only positive, remaining all negative. Here cos secant are positive in fourth quadrant, remaining are negative. That means you should remember, if suppose it is a lodge, this is the hall, receptionist hall, where we can sit, drink tea and read paper. All can allow to sit in this hall. So these are the rooms allotted. 3 rooms are there in lodge. This room is allotted to the sine and cosecant, sine and sine's wife cosecant, and this room is allotted to tan and tan's wife cot. That like that you have to remember. This room is the fourth room. Q4 is allotted to the cos and secant. Cos wife is secant. So only these rooms are allotted for those couples. But this is hall, belongs to all. All are positive. All can come and sit and read paper, and they can take a coffee also, or tea also, whatever it may be. But here others are not allowed. Only sine and cosecant is allowed here, because this room is allotted especially for sine and cosecant, and this room is allotted for tan and cot. This room is allotted to cos and secant. Like that you have to remember. So it is easy to remember. Imagine this is a lot. This is all are allowed in this hall, but this is specifically allotted to the couples, sine cosecant for second quadrant. Third quadrant is a third room or third quadrant is allotted to tan and cot, and fourth quadrant or fourth room is allotted to the cos and secant. That you have to remember. So according to that, signs will change. The negative sign and positive sign will be changes. Okay, is it clear? Next, copy it.